Good morning, boys. Welcome to the senior school and a whole new way of learning. I'm Mrs. Garg and I'll be taking maths for you. Today we'll be starting with the chapter Complex Numbers and Quadratic Equations. You all would have heard about so many types of number systems. One is the natural numbers, whole numbers, integers, rational numbers, irrational numbers and real numbers. So let's just form a small story kind of a thing to put them together so that you know which is smaller than with set. Now initially the questions which had to be solved were of the kind x, let's say x plus 3 equal to 7. So when you solve it, you get x equal to 4. Similarly, suppose you had to solve x minus 2 equal to 0 equal to 8. So when you solve it, it comes out to be x equal to 10. This kind of numbers, they form a set called as natural numbers. And they are denoted by capital N, and that's how natural numbers were introduced. Then slowly there were other kind of questions which came into consideration, that is, let's for example, if you have x plus 3 equal to 3. Okay, so when you solve it, you get x equal to 0. So there was a need to introduce this number 0. So when this 0 was added to the set of natural numbers, the new set so formed was called as whole numbers, which is denoted by capital W. With this, many type of problems could be solved, but slowly they came across problems of the kind x plus, let's say, 4 equal to 3. So when it was solved, it came out to be x equal to minus 1. Or similarly, other kind could be x plus 5 equal to 0, which could be solved to x equal to minus 5. This showed that there were some numbers which was neither part of natural numbers nor whole numbers, and this gave the mathematicians idea that there were some more kind of numbers which had to be introduced to this new set whole number. So when the negative numbers also were added to this set of whole numbers, the new set, which was called set of integers, was generated, and this is denoted by capital Z. Now with this, majority of questions could be solved, but then they came across questions of the kind 2x equal to 3, which got solved to x equal to 3 by 2, or 2x plus 3 equal to 0, which got solved to x equal to minus 3 by 2. This gave the idea that the numbers under consideration were still not complete and something more needs to be added to them, and this made a new set called as rational numbers, which are denoted by Q. Now these rational numbers include all natural numbers, means numbers of the kind 1, 2, 3, 4. The whole numbers means natural numbers plus 0 is the whole number. Then along with the whole numbers, if you have all the negative natural numbers, they form the set called as integers. All the integers along with the fractions, they formed a set called as rational numbers. Then they came across square roots of some numbers, or cube roots, or let's say nth roots of some numbers. Let's write it as cube roots or fourth roots, or these numbers, or recurring numbers. So such numbers, when these numbers are called as irrational numbers. Then all the rational numbers and all the rational numbers Q and the irrational numbers, they form a new set called as real numbers, and they are denoted by capital R. So if we see the it's something like this, that n is the smallest set, you add 0 to it, you get whole numbers. So n is all numbers of the kind 1, 2, 3, 4 and so on. You add whole numbers to it, you get add 0 to it, you get whole numbers. Then you add all the negative numbers, -1, -2, -3 and so on. It forms another set called as integers. Then you add the fractions, numbers of the kind p by q. Along with this, they form sets called as rational numbers q. And then along with these rational numbers plus irrational numbers, they form a set called as real numbers. So with this we could solve all kind of, this is called as real numbers. So rational plus irrational numbers, they are separate entities, they form set called as real numbers. Okay, now with this all kind of problems could be solved, even the quadratic equations could be solved. So let's say we could have but suppose we came across another quadratic equation of the kind, let's say x square plus 4 equal to 0. This gave us x square equal to -4, and as we all are aware, the square of any real number can never be negative, and so this led to the introduction of another set of numbers which will have the square as a negative number, and this is called as complex numbers. So real complex numbers are a set which is bigger than the real numbers also. It includes all the real numbers plus the numbers of the kind a plus ib, which I will be explaining just now, and these are complex numbers which we will be dealing with now. So that's how the need to introduce complex numbers came. Now let's study the complex numbers. What are complex numbers? Now for that, an imaginary number was introduced which is called as or denoted by I. Okay, and it is defined, it is a number which is such that I square equal to -1, which gives us I is equal to square root of -1. So that whenever you were given any number, so basically a new number was introduced to cater to the situation like this, that whenever we came across a quadratic equation or a square of a term which gave you a negative number, since the solution is not a real number, so imaginary number I was introduced, which is such defined in such a manner that I squared equal to -1 or I equal to square root of -1. Now let's see how this this helps us. Now given any number, let's say we got x square equal plus 4 equal to 0, which got solved to x square equal to -4, which can be written as -1 into 4, and which can be written as x square equal to 4i. In place of -1 we can write I square. So when you solve it, x becomes equal to this gives us x equal to plus minus under root of 4i square or x equal to plus minus 2i, and we are able to proceed further with such things. So that's the use of this imaginary number I. Now let's see what are complex numbers. Now complex numbers are usually denoted by small z, and they are numbers of the type a plus ib, where a and b are real numbers. They could be positive, negative or 0, and I is an imaginary number having value square root of minus 1. Now let's see how we can say that complex numbers is a set bigger than the real numbers. So given any real number, let's say 5, okay, so 5 can be written as 5 plus 0i, because 0 times any number is 0. So we can always write it as 5 plus 0i, which is in the form a plus ib. So it means that every real number is also a complex number. It means that complex number is a bigger collection of numbers as compared to the real numbers. Okay, so we have the smallest set. Now writing the sets in ascending order, when we write the number systems, what do we get? First comes the natural numbers, then comes the whole numbers, then comes the integers, then comes the rational numbers, then comes the real numbers, and then comes the complex numbers. Now let's proceed further with the complex numbers. So as we all know, complex numbers are denoted by small z and they are written as a plus ib. So complex numbers are numbers of the form a plus ib, where a and b are both real numbers, positive, negative or 0, and I is the imaginary number which is written which has value square root of minus 1. Now here when we write, so consider a complex number z equal to a plus ib. Now a is called the real part and b is called the imaginary part, and this is a complex number in the standard form. So like for example, if I have 2 plus 3i, 2 is the, and we write it as, we write z equal to this, so real part of z, and 3 is the imaginary part of z. If the number is, let's say, minus 2 minus 3i, then in the standard form we always have a and a plus ib. So we will write it as, it can be written as minus 2 plus minus 3 times I, and so this gives us the real part of z is minus 2 and the imaginary part of z is minus 3. Now how do we check equality of complex numbers? Now two complex numbers z1 and z2 are said to be equal if and only if their real parts are equal and their imaginary parts are equal. That is, if we are given two complex numbers, let's say z1 equal to a1 plus ib1 and z2 equal to a2 plus ib2, B2. Then Z1 equal to Z2 if and only if, or you can write implies and is implied by A1 equal to A2 and B1 equal to B2. Means that for the two complex numbers to be equal, the real part needs to be necessarily equal to the imaginary part, and real part of Z1 needs to be necessarily equal to the real part of Z2, and the imaginary part of Z1 necessarily needs to be equal to the imaginary part of the Z2. For example, you can see that if Z1 equal to, let's say, 2x plus iy and Z2 equal to 4 minus 3i. Given that Z1 equal to Z2, we have to find x and y. So what will we do? When are these two equal? When the real part of Z1 is equal to real part of Z2 and imaginary part of Z1 is equal to imaginary part of Z2. So this gives us 2x equal to 4 and y equal to minus 3, which gives us x equal to 2 and y equal to minus 3. Now let us start with the addition of complex numbers. Of complex numbers. Now two complex numbers, again we'll start with, let us start with two complex numbers, x1 plus iy1 and z2 equal to x2 plus iy2. The sum of two complex numbers is another complex number having the real part as the sum of the two real parts and the imaginary part as the sum of the two imaginary parts. That is, z1 plus z2 is another complex number having the real part as the sum of the two real parts and the imaginary part as the sum of two imaginary parts, is also a complex number. Okay, then addition, it implies that addition satisfies closure property with respect to addition of complex numbers satisfies closure property. Also, now addition is commutative, and this you can try it out, commutative. Then addition, there is an additive identity. So additive identity exists. Now what is the meaning of additive identity? Additive identity is another complex number which, when added to this, gives us the same complex number. Like for example, in real numbers the number is 0. Same way additive identity exists and is equal to 0 plus 0i. Then the next one is additive inverse exists. Now what is the meaning of additive inverse? Is a number which, when added to another complex number, gives you the additive identity. Like for example, for real numbers 2 and minus 2, they are additive inverses of each other. Whether you add 2 to minus 2 or you add minus 2 to 2, you will always get back a 0. So here you get minus a plus minus b I is the additive inverse, of a plus ib. Okay, with this you can try out some questions and we'll continue again in the next video. Thank you.